sí vamos a hacer más de una placa, ¿sabes?
Yeah, I think what I'm going to do to make life easy. No. Maybe if I take just one at a time. Yeah. I'll just do one at a time. Okay. Now, do you have one of the 8? No, actually, I can do. Yeah, I can do it. Yeah, so it's a bit awkward with the lids in the way. So normally when I do this, the DNA is in a plate that's like this as well, which is easier to work with. But if I just take a strip cube at a time.
No, ya la
Quite a
preparé.
high chance of contaminating these samples across each other because of the way I'm handling them. But
Es que está
I don't worry too
liofilizado.
much about that.
The thing is that I need to brush the tissue under microscope. So for that reason, I need
okay.
the strips.
Ah.
Because if I use a blade, I
Yeah,
can
yeah.
see when I brush.
So what was the DNA extraction protocol here?
Hot shot.
Oh, these were done with hot shot.
Yeah,
Okay.
but not for this, for Dayland, it's for Montero Pau.
Oh, okay.
Yeah.
So the volumes are quite, oh, I guess that's about 100.
Son tiras.
Porque la tapa. O sea, pero cada uno tiene su.
Cada uno tiene su. Ujú.
I will just, okay, I'll need a whole tip box for that. Can I use this one?
Yes.
I will just take that too. Since that's not really used. Alright, so use this. So 2 microliters. The amount of DNA going
Dos
into the
microliters.
mix. Small amount. So these being about 100 microliters each, you can potentially do lots of PCRs from one specimen. It's a very small amount per PCR. Okay, you always make sure your plate's oriented the right way, A1, H12. It's just like to, it's easy to flip a plate around and then all your results are upside down, so try not to do that. We already looked at the start that these things were in the right order, so it should be okay. Okay, so just hit yes. Obviously now you do need to change your tips each time because we're doing AH tips. So that's one. Not too much if I miss some of these. If you watch what tips you're on, it's easy to see if you lose count, you know just which row you've taken. So this is 3. You notice I'm sort of kind of pumping up and down a couple of times, and that does some gentle sort of mixing of the PCR mix. As well as helping to sort of wash all of the DNA, or as much of the DNA as possible out. Yes, you skipped the last one, that's the other end. Okay, great. So unless there's open, Samina, do you want to maybe close those?
Y el blanco. Sí. Todos fueron nuestros, ¿no?
So these are the PCR plate seals. It's kind of like clear tape, and they're sort of sticky. So we just peel those off. Do you have like a roller or one of those plastic things that you strip the plate down with? If not, you can also use the or just the edge of the plate. Yeah, that works too. So just pushing it down gently so it doesn't lose that plate here. You want to go around the edges, because otherwise if you don't move that, it's sort of not really a good seal. That's a good seal. See how that looks. The rest. You don't need to push too hard because these are actually these are sort of heat sensitive seals. So the PCR machine has a hot lid. It gets pushed down with a heated lid. The purpose of that is that it stops stuff that's evaporated from condensing on the lid. But it also has the effect of like partly melting the seal, so it will be really kind of tightly starting to seal down. You get most of that by melting. Okay, I'll do this gentle, just kind of a gentle tap to mix. Tap it on the bench to push it down. Yeah, most of those look pretty good. So generally what you would do is you would put this in a centrifuge, which spins down the plate, and that makes sure any liquid that's on the sides will get pulled down to the bottom. But we don't have that here. But it looks like most of them are pretty well down there anyway, so I'm just going to go ahead and put it like that. Okay, we're ready? So we will take this.
Aquí, come over here.
So I think we don't want this in with that. Let's just go straight with that. So we already programmed the correct thermocycling program into the machine. So we're just slotting like that. This is the heated lid. It's got a thing on it when it's hot. Close it down. Save the protocols. Loosen it and figure out where we actually save it. Yes, that's the one. Okay, so I'm just going to do run pro one. It asks you for the volume in each well, which is about 12 microliters. 10 microliters of master mix plus 2 microliters of DNA. The reason it needs to know that is that it's sort of calculating how the temperature is changing. You know, if it's a bigger volume, then it would take a longer time for the temperature inside the tube to reach that temperature. But this is 12 microliters, so it's quite small, so the temperature is going to change each time. And that's it, it's going. So the first thing it does is heat up the lid. So it's telling you the lid is at this temperature, 33 degrees, sample. It's still holding the sample about room temperature because the wheel program hasn't started yet. Surprised how fast this is. I've just spotted a mistake. I'm glad I spotted that now. We didn't run that. Yeah, we're going to cancel this. This go-to, where it's supposed to be going to step 6, it's actually going to step 8. So what it would have done, if I hadn't caught that, is just cycle this 72 degree step 39 times, which is not very useful. I want to do this, I want to do 94 degrees, 51 degrees, 72 degrees. I want to do all 3 of those 3 times. So how do I go back? Okay, save protocol. Step 6. So now it's going to 94 degrees. So save.
Solidaten.
And now I run, and I'm expecting it to be about 2 hours. 2.5 hours, yeah. So that was why. When immediately said when it was only going to take an hour, I thought something's not right here.
Okay.
Yeah, okay. So we're going to go for lunch. And then after lunch we have another lecture that's going to be back up in the room. So that will be time for, after all that, this should be finished and we'll be able to run a gel and see what the results look like. So, yeah.
Okay, so